Good evening, Damuni Topi. Good evening. Hello. Damauni, are you there?
Good night, sir.
Good evening. Good evening. Now how did you get the link?
I got it from Moodle. I was going to copy it and send it to this group chat we have on Telegram.
Yeah, can you do it quick as, because there was nobody in the last class. I was the only one, and today now about 5 minutes gone, only one person. But last week I had the 32 students a sober class. So it's keep going 1 week behind now. So you have a WhatsApp group for the other subjects?
It's on Telegram.
Telegram, yeah. Oh, all right. Can you send it the please and ask them to come quick as possible?
Okay, sir.
I'm going to put you as the co-host, right? Then you can admit them from the
Waiting room.
waiting room. All right?
Okay, sir.
All right. Make a noise when you admit the people, right?
Okay, sir. Someone's here.
You can add them now. Good evening, Natasha.
Good evening, sir.
Yeah, good to see you. Good to see you. We have one. Yeah, we have about four now. What happened to you guys last week? Nobody came to the class. Why?
Sir, I saw your message on Moodle very late. Class was already over, sir.
Oh, that is you came. Okay, yeah, one person came after half an hour after finish the class. Say that was you.
No, sir, I came about 45 minutes after, so I know that I was going to miss it.
Yeah, but when somebody go and click the link, I get the email that somebody came half an hour about
It
after.
was me, sir.
It was you.
Yes, sir.
That's Natasha.
Yes, sir. But I didn't see the link. I saw where you had sent the message that you had posted it from in the morning, but I didn't see it on late until it was late.
Interesting. I had a Zoba class last week. 32 students had registered and 32 students were there. 100%.
Ooh, that's
Mhm.
good.
Yes, you guys, I don't know. It's skipped. Not a single person was in the
There
class.
is it's a one-off thing. We'll be here every day, sir. When every time we have class, we'll be here. That's a one-off thing.
Yeah, but we missed the first class. That's the most important class. And today is still 4 people. Now 7 minutes gone. I don't know. It's skipped. But yes, last week, um, that was Wednesday. Wednesday, when I went to the site in the morning, only 8 people were registered. I don't know how many because the Moodle down today, no?
Yes, sir. It's not down completely, but it's moving very slow, so it's frustrating.
Oh, okay, okay.
Hello? Anyone talking? I'm not hearing anything.
Oh, we're hearing you.
Yeah, that's right. I hear you.
It looks like this is how much is going to come today. Um, now, because of we missed the class last week, I'm going to do the lecture. We cannot miss a whole week. Normally, people during the first tutorial hour, I give you guys an introduction and then put them into groups. And then do little introduction to the class and introduction to the syllabus and blah blah blah, those things. That normally take 1 hour, but if I miss a 1 hour today, the lecture going to go until 10 o'clock. You get what I mean? Because lecture I need 2 hours. So hence, because we're going to meet again tomorrow for labs, um, I'm going to do the introduction part tomorrow. All right, people.
Yes, sir.
Yeah, because I don't want to go the class until 10. You guys are the one who going to complain. Last semester, some people complain I overrun my allocated hours. So timetabled hours. All right, say what I'm going to do, but I need a quick contact. Not contact. I need to appoint the class rep. Can somebody volunteer quickly because we run out of 10 minutes already? Who is going to be the class rep?
I'll take it.
All right, Natasha. All right, what you going to do, Natasha? You're going to send me your contact number. You have my email address. I'm going to give you I have two email address. One for communication, one for assignments. I'm going to put in the chat my communication email address. Send me an email and then I'm going to give you a contact number, WhatsApp number and a contact number. That is only for you. You are not going to redistribute. But the class, due to any problem they have, they're going to call Natasha. And Natasha can call me up to 9, 9:30, 10, up to that time in the night, if it is urgent. All right, damitwick@gmail.com. This is for communication only, not for assignment. Okay, send me an email. When you send the email, put your number also. Natasha, are you hearing me? What happened? Are you hearing me, Natasha? Microphone dead. Your microphone dead. Natasha, are you hearing me? Your microphone. Switch on the microphone.
Yes, sir. Yes, sir, I'm hearing you.
Okay. Did you see my message? I send you my email address. Clear?
Yes, sir, I'm right. I'm taking it down.
All right. What basically for the until we meet again tomorrow, I will give you all the materials you need, whole class need, right? All the assignments, all the lab work, those things. And what you need to do, think about that assistant class rep or deputy class rep to help you. We need very strong class rep and a deputy because it's not the normal time. Everything is online. Communication is very important. And I will talk a little bit more on introductory part to the class, but I am going to run to the lecture now. I'm going to send you the first lecture note. I'm going to send you the first lecture note. And also, Natasha, can you divide the class into 4 groups? I don't think we need more than 4 groups. Right?
So you're talking groups of two,
Yeah.
right?
Sorry, go ahead.
Based on how many participants, we only have 6 students in class.
Yeah, what you do,
Yeah.
what you do, divide them into 4 groups, but first group will have 3 people and every other group has 1. Am I right? Clear?
Yes, sir, yes.
First group, you will be the class rep will be the group leader, and then the assistant will be the group leader for group 2, and then you need 2 more group leaders. But anyway, first group has 3, second group has 1, third group has 1, fourth group has 1. Clear?
Yes, sir.
Yeah, there were 8 people registered last week when I check it. But you know, skit always come up to 5th week. That is the problem I am having. Good. All right, let me jump into the lecture because I don't want to run the class until 10. We might go until about 9:15, 9:30 today. All right.
Yes, sir. I have no problems with that.
Good. Very good. Anybody resitting this module? Anybody here resitting? Anybody? Nicholas?
No, sir. No, sir.
No. All right. First timers. Okay. Now while I am, how I'm going to, did you send me the email? I can send you the lecture note.
I'm typing it now, sir.
Send you the email. I can send you the lecture note first.
Okay, sir.
Yeah. send it?
I sent it, sir.
Okay, let me see. I don't see it yet. All right. I'm going to attach it. Where is my computer? D. UTech DBMS to let me save this. Did I put it? Yeah, I send it to Natasha. Natasha, are you there? Hello.
Yes, sir, I'm here. I'm here, sir, I'm here.
All right. What is your? Did you send your contact number?
Oh.
You
Let me
forgot.
reply back. Let me reply back with my number.
Let me type it here. Let me share the screen. We are running out of time badly. All right. You can see my screen. What is your full name, Natasha?
Natasha Thomas.
Natasha Thomas. And what is the number?
875 3199.
875 3199. That's it?
Yes, sir.
All right. And this is going to be, let me save it. All right, people in the class, please note it down, please. Your emergency helpline. Natasha, I think A missing. All right. And Natasha, send me your number and then I will send you a WhatsApp. Okay.
I sent it in the email, sir.
All right. I'll do it at the end. All right, people, let us start our lecture. Um, Advanced DB. All right. Advanced database. Now, everybody here, let me get a little introduction. Now, 7 people. Out of these 7, how many of you guys are what we call ES database people? How many ES people out of these 6?
Enterprise system, sir.
Yeah,
I'm one of them.
Janoi. Who else?
Me, I am one.
Okay, Natasha, Janoi. Who else? All right, only 2. But those 2 guys, remember.
I'm one, sir. I just changed from computer science.
Or you came from computer science to ES?
Yes, sir.
Okay, 3. All
Sir,
right.
I'm ES as well.
That's who?
The money.
Dem, Demo. How do you pronounce your name?
The money.
Damani. Okay, yeah. Now, why I am saying, remember, Advanced DB is the last theory class for you, the ES people. Don't joke it. You're going to have issues when you start working. Not to start working even for anything else. When you have to do data mining, you have to do database administration. The theory that you need, we cover in advanced database, right? So you have to understand the concepts, people. Otherwise, you're going to have an issue with database administration and even data mining. Say, especially ES people. Others also need to understand, but ES, you cannot continue with ES. Now, what you have done already, database design. Database design, what you discuss at database design, I don't know whether you understood, there is a very, very important thing in database design. What is it? What is the core part of database design? Anybody?
Normalization.
Yes, that.
Yeah, normalization is a very logical step. All right. Normalization is also very important, but that is not what um, I know it is the hardest part for you guys, but there is the that is, you can say, yeah, logics, concepts, but your design, your entity relationship diagram, that's the most important, right? Your entity relationship diagram, drawing the entity relationship diagram is the most important part of the database design, ERD. You have one-to-one, one-to-many relationships in the ERD. Am I right? Clear?
Yes, sir.
Yeah. And
Yes, sir.
this one, entity relationship diagram, we call conceptual diagram. Am I right? Conceptual diagram also, we call it conceptual diagram. Did you heard the word? Did you heard the word conceptual?
Yes, sir.
All right, good. Now, when you were in the last semester, you talk about you talk about 3-layer architecture. You remember the three-layer architecture, people? Do you remember the three-layer architecture? Anybody?
Is it the presentation, business layer, and then backend? I don't know. I guess
Good.
it.
You very good. That was the first lecture in database design. Lecture 1, three-layer architecture. Anybody?
Sir,
Anybody?
we're trying.
Nobody? Try it,
A
man.
while.
Try it. Hmm?
Sir, we're trying to remember. It's been a while.
What do you mean by it been a while? Just few weeks ago.
No, sir. I did mine a good while now, sir.
Anybody? Anybody? But those are the theories. Those are the, remember, entity relationship diagram, three-layer architecture.
Sir,
And
is
that is
it
where we started in the
the external level, the logical, conceptual, and physical?
exactly. Who is that? Who is
The
that?
money.
The money?
Yes, sir.
All right, good. Yes, three-layer architecture. The bottom is we call physical, and this is also called internal. And then this is called logical, and also another name. Anybody?
Conceptual.
Conceptual. And the top one?
External.
Huh?
External.
Yes, external. What is the other one?
Sir, I don't know the other name for that one, sir.
Yeah, use of use. This is what you see. Or external. Yeah, those interchangeably. This is what you see when you go to Midas. You see a screen. Welcome to the Midas. Please enter your login or your password. That is we call use of use. That is we call external layer. Your forms or your user views. And then in your last database design, what you did in your database design is this. This is what you did in database design. Only this. Your database design. Your first module in databases. You did logical layer. You design using entity relationship diagram. That's what you did. But this year, advanced database, we are going to talk about this advanced database. All the theory about physical layer, we talk about this. Now, advanced layer database will do little bit of this in the project, lab project. Lab project, you will be dealing with this also little. But I am not very much interested in, because the people doing ES has two modules, ES1, enterprise EC1, EC2. All you doing is this, converting the physical and connecting the physical layer to this. So hence theory about physical layer. Now the design parameter of the conceptual level. What was the design philosophy? Anybody remember? Why do you normalize? What is the reason?
get rid of redundancy.
Why? Why you have to get redundant?
Performance.
Huh?
Performance.
No, sir. That's a pure lie.
Sir, is it
That's
for
you guys did the normalization. Did you ask your teacher why you do normalization? Huh?
sir, is it for data integrity?
What is the name? What is the name? What is the name?
Me, sir, what is my name?
Yeah, who said it data integrity?
The money.
The money, yeah. Natasha, class participation mark. Please put Damien 1 mark. Even though I didn't say I'm going to give, he give a 2 consistent right answer. Data integrity. In the conceptual design, the design philosophy is the,
Put the man his name for 1 mark.
yeah, please. You can put a little register and put him a 1 mark. Yeah. At the end of the semester, you can give it to me and I will add it to the research. Yeah. All right. So the design philosophy.
Okay, sir.
Yeah. Thank you, darling. Design philosophy for database design during the normalization and the design, everything was integrity. Integrity mean accuracy. You know, integrity mean accuracy. Nothing else. Accuracy. That was the design philosophy. We did normalization. If you don't do normalization, there is redundancy. Redundancy means duplicates. If you have duplicates, you don't know which one are you updated, and then there is going to be a contradiction. We don't know which one copy is updated and which one is not, because there are 2 copies of the same data. And hence, we have to minimize. We have to minimize or remove redundancy or duplicates, but we cannot 100% remove, and hence we reduce. That is what we call normalization, accuracy. But anyway, now I'm going to do physical layer design philosophy, called design philosophy. Philosophy. My English is wrong, accurate, but anyway, you know, design philosophy. Design philosophy is design philosophy for physical layer. What is it? Anybody? Anybody can try? You want to guess, Damani?
Sir, repeat.
What is the design philosophy for physical layer design? That's what we're going to do this semester. Guess it.
The design.
Remember, accuracy or integrity was the logical layer design.
Right.
What is the design philosophy for the physical layer?
I'm not sure, sir.
Try it.
Topological is integrity, physical. Sir, can you give a hint?
It's a 1 word. It's a 1 word like logical, because every aspect, whole semester, this is what we're going to look like database design. Every aspect we have to make sure. If you put the word apple, and the word apple should come without a change. If we put Natasha has 2 boyfriends, and when we query the database, and the database should give Natasha has 2 boyfriends. That is we call integrity or accuracy. But
So
physical
that should be consistency, data consistency, sir?
accuracy and consistency is the same.
Oh, okay.
Yeah.
Does it have to do the integrity of the data? No, like where they write this so.
Secure. Is it where it starts with S, sir?
Huh?
Security.
No.
Sir, what do words start with?
Integrity and security go together, not the security.
Okay.
Say what the word started.
All right. Anyway, I'm going to give you speed.
Oh, sir,
Speed,
we would have
speed,
guessed that, sir.
speed.
Performance.
Everywhere we go this semester, we talk about speed. How to accelerate the data retrieval. How to speedify this. How to speedify this. Everything physical AI speed. Because you know, if you have to go to look at what was going on. You go to the Moodle rotating, 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 and nobody go after that. If you're going to use the Midas card, and then you put the card and you had to wait half an hour to get the input screen, nobody going to use it. So the speed is the most important, and then we're going to talk about speed this semester. Now, before we go to discuss about the physical layer, now what is the physical layer? Basically, the physical layer where we store the databases. We store the databases in hard disk. Am I right, people?
Yes, sir.
Yeah, hard
Yes.
disk. Can we store databases in the tape drives? Can we? Yes or no?
In what, sir?
No, no, sir.
Why?
The speed.
It,
Tapes are slow.
exactly. We cannot store in tapes. We used to store the backups on tapes, but not databases. We keep a backup for security, but databases has to be in a hard disk. But there are new technology coming, like flash drives, databases on flash disk, right? But still the flash disks are very expensive. Hence, it is good for extra or small databases, but not very good for large databases. But anyway, databases are large. Hence, so far, we are storing in hard disk. But I will give you something to read about, because in the future, maybe another 4 to 5 years time, there will be flash disk or SDD, right? SDDs will be used to store databases. But currently, my um, um,
Sir.
SSD,
SSD, sir. Solid state drive.
yeah, solid state, sorry, SSD. Say not yet much, right? Say hence we're going to continue hard disk. Hard disk is having moving parts. Moving parts mean the disk inside rotating. But SSD completely different theory. Hence, the today's lecture is all about hard disk, how to calculate the time consumption to take out a record of data from a table. Because we talk about database tables, because we're talking about relational databases. Say now, so let us talk about now how the hard disk store data. Now, before I'm going to hard disk, I'm going to give you a little description of um, the methods or some of the terms that we use in the storage. If you if you there are similarities. Now, if you go back to the history of shipping, if you go back to the history of shipping, the Jamaica is a country, and you know, Jamaica is the only country, I think, in the world that import 100% its main starch. that is rice, because we don't grow any more rice. Now, this is the ship. In those days, I can't extend it, but anyway, the ship in 100 years ago, 200 years ago, the rice come on the ship hull. This is the rice in the ship hull. Now when the rice come in the ship hull, people jump into the ship and use shovel. My diagrams are not good, right? And then this is a bull cart. My drawings are not good. Where's the bull? This is the bull cart. Yeah, that's the bull cart. Her wheel is little bigger. I put the rice or paddy from the ship to the bull cart, and the bull will carry from Kingston Port to up to Ochi, Montego Bay, or wherever the distance. That's how we ship rice, but not anymore. We changed the industry completely into a different level. The new ships does not carry the goods in the hull. The new ships carry something called, anybody know what they use now? What do they use now? What do they use now?
Containers.
Thank you very much. Exactly. They use now containers. No more hull business. There are so many advantages when you use containers. They are all the same size. When the containers come, they have cranes lift the container and put into the truck. All are the transportation method. Very easy and very fast. Now, but we import now cars. Let me take into a different sub type of materials. The rice also can bring in the containers, but suppose we bring cars, right? Now, assume each 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 container can carry 3 cars. 1, 2, and 3. All right, 3. And this one also 3. Like that. All right. Now my question is this. There are 5 cars coming to Kingston. When the ship come from Japan with the cars, it carry all the load to the Caribbean. All right, not only to Kingston. So it come to Kingston and then to Cayman, then go to Trinidad and go like that. Now 1 car came for Trinidad and Tobago. 5 to Kingston, 1 to Trinidad. Now, the remaining car, they're going to put it in this one, or they're going to get a new container and put. How it is going to? Anybody try it?
Sir,
Yeah,
you're asking which one would they put the one for Trinidad Tobago
yeah,
in?
yeah.
I would put it in the one, the singular one by itself.
What is the reason?
Because
What is the reason?
if you said that you're going to remove each crate and put it on whatever transportation or whatever to go off, it would make sense for you to just put the one car by itself. That way they can easily move the other two crates with ease without having to take out one car and then move it afterwards. That's just how I see it.
That is Damian, no? Damian.
No, Leon.
That is Leon.
Yes,
All right,
sir.
thank you, thank you. Leon says we're going to need 3 containers. Am I right? We're
Yes,
going to
sir.
need 3 containers. All right, Damien say 3 containers. Now, anybody else? What about Damien? Damien was there or gone?
So what was the question, sir?
How many containers we going to need to carry 5 cars to Kingston and 1 car to Trinidad?
Uh, yeah, 3, sir. Because you said one there has 3 in it and the other one. No, 2, sir, 2.
2.
Because the extra one. Wait, sir. No. Because the one going to Trinidad would probably need a separate container for itself.
So what is your answer?
So I would say 3.
3. All right. Both of you say the same. Anybody else different answer? Anybody else?
I'd say 3, sir.
Okay, 3. The answer is 3. The reason, there is a law. The shipping industry has a law. What is that? When this container comes, you cannot open the container until your buyer or the owner of the container come to the port. The container has to be open in front of the buyer or the owner of the container. In other words, to open this second the second container, we have to ask the Trinidad man to come to Kingston. Am I right? Am I right?
Yes, sir.
Yes.
And I think that's something to do. Based on what you were talking about earlier about speed, also, sir.
Mm.
I think you would have taken up more time if you put one of the cars in the container to take out back and then put back the container so that you can ship it to Jamaica, so that and so forth.
Yeah. Yeah. That will okay. Yeah. But the container laws, right? Container laws says you cannot open it if the owner is not there. So in other words, hence we cannot put the um, Trinidad car in the Kingston container. So hence you have to put that car in the third container, and you need 3 containers. Now this theory, container theory, apply to databases also, as it is. In databases, we move records exactly as this shipping business, container business. In other words, what I say, now database record, database tables, we have tables. We have table. I don't have much space, but let me draw. People can see the screen.
Yes, sir.
All right. And then let me draw another line. We have record 1, record 2, record 3, record 4. All right. Say this one is a ID, and this is surname, and this is first name. All right. And then there is, I'm not going to fill the data, but we see some information is there. Some information is here, some information is here, some information is here, some information here. All these are filled, right? Now, what we do, this one row is a one record. People, you remember first year IT, and every row is a record. Now, what we do, one record is a one car. One record is a one car. Now, in normally, we can assume we can put 3 records in a one block. We call this is a block. Block. One block. Say block equal to a container now in the shipping business. Block equal to a container in the shipping business. Block. Say one container has 3 cars and one block has 3 records. It can be 4 if the records are, if you are putting bus, you can put only 2. Bus is bigger than a car. Similarly, if your records are longer, like ISAS student table, record is big, maybe you can't put more than 1 record in a one block. Now, here, one block is assume 3 cars, and now when we want to move hard disk to the RAM, you know, when you want to change any data, suppose surname, Natasha married Topel, and Natasha's surname is changed to the Thomas to Topel. We need to take, suppose Natasha is the first row record. We need to bring this record to the RAM memory if you want to change it. We can't change it while it is in the hard disk. Now, when we bring this record, we cannot bring a record. It is illegal. We have to move one full block. It is a block movement. It is a container movement from hard disk to the RAM. Remember, in databases, everything moves as blocks, not individual data items. So we have to move this one to the RAM and change the Thomas to Topel and put it back as a block into the hard disk. It's a block movement, container movement. Remember, that is the difference between the databases and non-database data. The non-database data, example, video, images, anything else, you can move by bits and pieces, bits and bytes, or bits, and you can change by bits. but not database. Database you can move only a one block. Remember, that's very important for anything else. Now, in the people who are doing, um, the people are doing um, operating systems theory, right? Some books use this block equal to a page, block equal to a page, but I am not going to analyze it. For the time being, assume one block is a one page, but when you go to the operating systems, there is a difference. The block is a logical thinking pattern, page is a physical actual thing. So hence, these are, even though we assume it is equal, page equal to a block, but actually it is not. Clear? But for your database, assume block is a page. People, are you clear?
Yes, sir.
Yeah. Now, because of we have a 1 hour, I'm going a little faster because I don't want to you guys complain that I'm
Yes, sir.
overrunning. Yeah, I'm overrunning my allocated time. Clear? But if you are not understanding us, I hate to run. I hate to run because it doesn't make any sense running on the lecture. If your class don't understand, if I'm running to cover it, it's waste of my time and it is waste of your time. But unfortunately, this new normal, we have to teach within 2 hours distance. It's almost impossible to teach face to face 2 hours. You cannot teach distance 2 hours. It's not equal. Unfortunate, what to do? Now establish how databases move data, block or container, right? And then anywhere now we are going to do further, I talk about block. Now there's another term. Unfortunately, see, I don't have a big whiteboard. I don't know whether I can save this. Yes, save. I'm going to define a term called blocking factor. Blocking factor means number of blocks, number of records in a block, number of records in a block. Now in this diagram, blocking factor is actually, how much is the blocking factor in this diagram?
3.
3. Very good. Blocking factor is 3. Then normally, if the question, the final exam first question is this, if it does not give you blocking factor is 3, you make an assumption in writing. Assume the blocking factor 1. Okay? Because some past papers you can see blocking factor is not given. But do not assume 1 without writing it. You lose 5 marks. Remember that. You can assume, but write it. Assumption, blocking factor equal 1, and then continue the question. All right. Having said now, little bit more thing I want to show you. First year IT little bit. Let me change my screen share. I updated my lecture note. Oh, remember when we finish the class, Natasha, don't run, okay? Because of the first class we miss. I have certain things to tell you. Because I have to give you what I'm going to do, people. I'm going to email you the most important things. They are on the Moodle, but Moodle is down. Even though I'm not responsible for that, but I don't want you guys at a disadvantage. What I'm going to do, I'm going to email you the textbook also. I'm going to email you the PDF, illegal PDF version of the textbook that need for test 1 and test 2, the textbook that needed for test 1 and test 2, and the other book that you needed for final exam. 2 books I'm going to email you. And the lecture notes, all the lecture notes I am going to download and send it to you tonight. Natasha, did you hear?
Yes, sir.
Yeah. And I'm going to send it tonight. And the other one, Natasha, remind me to talk about labs tomorrow. What to bring in the labs tomorrow. Clear?
Before we planning to talk about what to bring for the lab tomorrow before class ends.
Yes, exactly.
Okay.
Yeah, at the end of the class. Yeah, because that is also important. Right?
Okay.
All right. Now, this you can see this diagram, people.
Yes, sir.
What is this?
A hard disk drive.
This is the hard disk. Very good. So you have seen this first year IT, and then in your CXC computer IT, CXC IT, you have seen this diagram. Simple diagram. This is actually a floppy disk. Can somebody tell me the difference between a floppy disk and a hard disk? Is there a difference? And if there's a difference, what is the difference? Quickly. First year IT, common sense. This is not the database design, neither advanced database. Is there a difference between hard disk and a floppy disk?
Sir, hard drive, the disk moves. I'm not sure about floppy disk. We don't really know about it. I'm not sure if the disk moves.
No, I didn't hear. I didn't hear proper clearly. Go again.
For hard drive, I know that the disk spins in order to find the data. For
Mhm.
floppy disk, I'm not sure if the disk spins.
Oh, there is basically no difference between hard disk and a floppy disk. Same thing. Same philosophy, same everything. There's a very small difference, in negligible. The in a hard disk, the hard disk driving motor mechanism is built into the hard disk. It's inside the casing. But floppy disk, the motor and the read write head. See the head? You see this one? You see this? People, can you see what I'm showing?
Yes, sir.
Yeah.
Yes, sir.
That one and the motor is attached to the computer, and the disk you can take out. Two different things. This arm and the motor we call floppy disk drive, that is attached to the computer CPU. That is the only difference. In a hard disk, the disk and the mechanism to drive the disk, rotate the disk, is in one unit. That's the only difference. But if I analyze a little bit more, hard disks have more capacity because in a floppy disk, it is only one disk or one platter. Platter mean disk. Platter. One platter in a floppy disk. But in a hard disk, there are more than one platter. You can have 4 or 8 or 60 or more. That is how hard disks have more storage. But people, you learn this one for the IT, CXE IT. Am I right? Hmm?
No, sir.
Jesus Christ. Why not? I can tell you which page. in the CXCIT book is there. And this is in the first year IT. You didn't learn these things for the first year IT either?
Yes, sir.
Of course. the But this is the philosophy. Hard disk and floppy disk, same design philosophy, same way it works. Only hard disk has the built-in mechanism to drive. But anyway, if you guys not remember these things, very important, especially ES people, storage mechanisms. Hard is not going to die, you know. Hard is have another at least 20 to 30 years lifespan or more. Because SSD technology is still not enough to save big storage. Um, Databases are terabytes. We don't have terabytes SSDs yet. I don't know. Maybe next 2 years time.
Repeat what you just said, sir, about terabytes.
Terabyte, yeah. What is the terabyte SSD now? One?
Yeah, man, sir, you're supposed to have about 2 terabyte now, in an SSD,
No. Check it and send it. I didn't check
Huh?
it for last month. I think there was a plan for 1 terabyte SSD about a month ago. I don't know whether it came out and what price.
Okay.
Yeah. Even it come 1 terabyte, it will be over 900 US dollars. And 1 terabyte of hard disk, you can get it for 10 US dollars now. Say, hence, when we are talking about massive databases, SSD not yet. You get what I mean?
2 terabyte SSD for $200, sir.
How much now?
$209.
Yeah. Say 2 terabyte hard disk, you can get it for 20 now. 2025. Say 10 times higher. And the amount of data, yeah, at least it will take 10 years more, 5 to 10 years to get into the real data storage. There will be applications like not real to store the databases, but to keep, like I have SSD on this computer to keep the operating system. You understand? To keep the
Yes, sir.
operating, yeah, to keep the operating system, I put SSD on this. Most of my laptops I put a SSD, actually a card, SSD card, because operating system, if you are switch on the computer and if the operating system coming from hard disk, it takes about at least 1 minute to boot. But if you have M3, I'm using M3 or M2 card, SSD card, that is about 10 seconds it boot very fast. That is the advantage. But it is 32 gig. 32 gig does the job and cheap enough. But anyway, I will give you a small assignment or read about on those things. All right, let us move, people. We are running out of time already. Now, here now, in a floppy disk, tracks. It's like a playground. Playground has tracks. Say these are tracks. This is the outermost track, several tracks. Now, the area between two tracks, see this area, right? This area we call a sector. Sector. See that? There we have track and then a sector. And then this is the read-write head, right? And this read-write head, this head has a mechanism. Now you guys have seen record vintage record players. Am I right?
Yes, sir. Vinyls.
Yes, sir.
Vinyl, exactly. In a vinyl record player, exactly the same thing. Those are magnetic records. But only difference between this hard disk and that, in the vinyl player, the record, the pin go and touch the plastic. Am I right?
Yes, sir.
Yes,
Yeah,
sir.
pin go and touch. But here the read write head does not touch the platter. It is magnetism. That is why we call this is magnetic drives. In the first year you heard this is magnetic drive. What is magnetism? Anybody know what is magnetism? What is magnetism? Magnetism means a magnet can absorb a piece of iron. It attract. Am I right?
Yes, sir.
Exactly. It attract. Say now, what happened when the read write head? It doesn't touch the platter or the surface. When it get close to the data, it can absorb the data. It can absorb without touching it. Same is a tape cassette player. The head does not touch the tape. It gets very close, and by magnetizing it, the head absorbs the zeros and ones, that is data in the sector. That is how it reads. And it write also the same way by using magnetism without touching. That's why we call it magnetic data storage devices. Use magnetism. Good. Now this is still I'm teaching you guys the first year. All right. Now let me go to the now. Now this arm movement, right? This arm movement. Watch it my diagram, everybody. Arm movement is from here to here. This is the direction of the arm movement. All right. And the disc rotate like this. Rotation. This is the spindle. In the middle is spindle. The disc rotate around the spindle and the arm move from here to here. Like when arm station here, when the disc rotate like this, it can read the full all the sectors in between these two tracks, all the sectors. And when it arm move here, second one, it can read all the sectors. So in other words, arm movement is linear. It move on a one linear path. Let me show you here. Now this is a hard disk. Previous one is a floppy disk. Look at multiple platters. See that? Multiple platters. And this is the arm assembly. Why? You have to have a read-write head for the top surface, and we store data on the bottom surface. Because if you use both top surface and bottom surface, we can store more data. So by using 6 platters, we have actually, sorry, 3 platters, we have actually equivalent to a 6 disk or 6 surfaces, twice the data. So hence, we have 6 read-write arms, 6. Now this arm move now up and down linear. See, up and down linear. See that? Up and down linear. Then it can reach all the tracks from here to here. The arm assembly move, we call arm movement, is linear. And a spindle rotate. Now, if you see now, look at this. This radius and this radius and this radius is same. People, did you notice that? Are you watching? People, are you
Yes, sir.
watching?
Yes, sir.
I'm still teaching first year IT. Now, this is radius same, this radius same, this radius same. Now, if I put this vertical line, look at this. This is a cylinder. This is a cylinder. This is a cylinder. Look at this. This is a cylinder. Now, why? The cylinder is a concept. Cylinders are not drawn in a hard disk, but it's a concept, logical concept. Why? When this arm movement stop in this location, all the data in this cylinder can be read without further movements. That's a very important concept in database theory. Cylinder concept. That is why we talk about a cylinder. There is no cylinders created inside a hard disk, but it's a concept. This arm assembly without further any movement, when it is stationary in one location, we can read one cylinder, that is huge amount of data, because it has this, right, this track and bottom track 2, 3, 4, 5, 6, 6 tracks of data, not one, 6 tracks of data you can read without further movement. We're talking about the speed. We talk about the speed. This linear arm movement is the slowest. This arm we call is an elephant. Why we call elephant? Very slow, extremely slow. So elephant can't move. So hence, we want to read the data, whole heap of data, without arm movement. That is why we put the data that we frequently read, the frequently read data we put into a one cylinder. Then we don't need to move this arm. That is what we call cylindrical concept. People, now we are still not in advanced databases. Good. All right, now let me introduce you to a formula that is advanced databases. The time consuming, the consumption, time consumption to collect, to read a block, time consumption to read a block from the hard disk and send it to the RAM. The time consumption to read a block of data from the hard disk. Suppose this is the block of the data, right? One block of the data from here, right? Read it, right? Suppose this one. Absorb it to this one, read write head, and then move it from here, and then send them to these controller modules, and then send into the RAM. How much time it takes? Now there is a formula to move block of data. Block of data. Let me come. Yeah, T. Block of data. See, to move a block of data. TB actually, it should be TB. Right? T equal A plus R by 2 plus L upon D. I'm going to show you very simple to prove this one, right? You guys can see T equal A plus R upon D plus L upon D. All right. Let me go to my white screen. All right, let me save this and then clear all. All right. How this come? Let me see. I can split this screen. I think I'm going to draw it. All right. All right. Now I'm going to draw it. The track 1, track 2, track 3, track 4. That is the spindle, and this is the read right arm, and read right arm can move read right arm move up and down only, and this is the read right arm. All right. Now data block. This is the data block. Data block. That's the data block to be read. That's the data block. Data block to be read. All right. Now assume this read write head was parked here. All right, parked here. Now this read write head has to move from here to here. That's the first thing. Read write head had to move from here to here. Now in this equation we have T equal T for a block equal A plus R upon 2 plus L upon D. All right. Now the A is this read write head to move from one track to another. But this one moved from here 2 tracks. So hence we may think it should be 2A. No, it is A. The reason you remember, I say the read write arm is an elephant. You know, elephant is one of the fastest animals. But when elephant lie down, for him to start running takes time. It's about 2-3 minutes it takes to stand up in 4 legs. And then speeding. To increase the speed take time. But once he increase the speed, nobody can run with an elephant very fast. This one also the same. Read right arm, when it is in stationary, to energize and start moving takes time. But to move from one place to another track, or from outer track to the most inner track, there is no difference. One start moving, it's move very fast. But to energize and start moving take longer time. Hence, compared to moving from outer to most inner, or outer to the next track, almost equal, no difference. That is why we assume the A is from moving anywhere to anywhere, but for a one move. That is A. Everybody clear what I said?
Sir, can you repeat the last part, please?
I don't hear you.
Could you please repeat about A? You said A is from any. Can you repeat that part, please? You said from anywhere to anywhere.
Yeah, anywhere to anywhere is A. Somebody asking a question? Whether it is one track or two tracks or three tracks, A is for one movement. Clear? That is the arm movement.
Yes, sir.
Yeah, arm movement. All right. Now, the second one is R by 2. That means now the arm move from here to here. But data block is here. And this rotate, right? Spindle is rotating. And now this one has to come from here to here. Right? Now we need to find how much is the time. Now we say R is the rotationary speed. Rotationary speed means how many seconds, all the times are in second. Remember, all the time are in how many seconds it takes. That means this dish rotate around the spindle. Say how many seconds it takes to rotate one round. How many seconds it takes to go one round. In other words, seconds per round. That is R. R is seconds per round. How many seconds it takes per one round. Now, here now, the data block. We have to do a little approximation. Why? We really don't know where is this data block. It can be here or anywhere. So what we do is this. We get the best case scenario plus the worst case scenario and then divide by 2. Now the best case is the data block is right here. Right here under the read-write head. To move it, time needed is 0 because it is right under the read-write head. That is the best case. The worst case scenario, the block was right below, just past. Now it has to go one round to come back. The time taken for one round is R. Now the best case plus worst case divide by 2. We average out. Now this will equal to R by 2. That is the second factor. We call rotational delay. R by 2 is the rotational delay. And A is the arm movement. Now the third part now. Now the block is right under this read-write head. And now left is using magnetize it, absorb it, transfer it through the mechanism and send it to the RAM. Now to do that, we calculate the length of the block in bytes. L is length LEN of the block in bytes. Why? What is happening here now? Huh? I can't type. I'm using T. L length of the LEN of the block in bytes. Okay, it is in bytes. Length of the block in bytes. That is L. Because if it's a bigger block, it takes more time. If it's a smaller block, it takes less time. Say length of the block, right? And how many seconds? D is how many seconds it takes to absorb and send it to the RAM. D, that is the speed. D is speed of transfer. That is bytes per second. Bytes per second. Say now L upon D, that is bytes divided by bytes per second, will come finally seconds. Say remember this T is in seconds. T is in seconds. Time for a block of data transfer in seconds. Remember in the exam, it has to be, everything should be in seconds, right? Not milliseconds. Seconds, this is seconds, this is seconds, and this is seconds. All are in one unit. Right, any questions, people? No. What I'm going to do now, I'm going to do a small question. I'm going to do a small question. You can't see my screen. I'm going to hints. This is the lecture note 1. This is the question. This is the question. Can you guys read the question for 1 minute, please? All right. Now, A. A is what is A? Arm movement. It says 30 milliseconds, but we can't put milliseconds. We have to convert into seconds. How do you convert seconds into milliseconds into seconds? How do we convert milli?
Divide by.
So we divide by 1,000.
Divide by 1,000. Exactly. That is grade 5. Am I right? That's grade 5, grade 6 work. Hence, I'm not going to go. Divide by 1,000. 30 divided by 1,000, you get 0.30. Good. Now, revolutions per second. Remember, the R we get 3,600. The disk unit rotates at a speed of 3,600 revolutions per minute. 3,600 revolutions per minute. Now, that is the problem, people. I know you guys don't like divisions. This is 3,600. That is the rotationary speed, but it is a different value. 3,600 revolutions per minute.
So sir, we have to divide the 3,600 by 60 to get how much revolutions it makes per second.
Per second, exactly. So we divide it by 60 to find per second. That is 3,600 divided by 60 will become 60 revolutions per second. But that is not R. This is not R. R is how many seconds per revolution, not revolutions per second. See, remember I defined the R as how many seconds it takes for one round. In other words, bolt speed, it was 9.9 seconds per one round. But here, right, it says revolutions per second. So hence, we have to make it upside down to make it seconds per revolution. Are you guys understanding, or you want me to go with it? Do you understand? Now, let me,
Can go over that again for me, please.
what we have is R is what? How many seconds it takes to go one round? How many seconds it go for one round? That means seconds per round. R is seconds per round. But what is given here is, in the lecture note, given here is how many rounds per second. That is 60. That is 60 rounds per second. If I get rounds per second, say rounds per second as, let me get as S or C. This, no, S, say S. This is S mean rounds per second, right? Rounds per second. S is rounds divided by seconds. Seconds under here. But here, seconds per round. You see that? This is seconds per round, and here is rounds per second. What is the difference? You have to move upside down. Am I right? People, are you watching?
Yes, sir.
Yeah, we're watching.
This is rounds per second, but we need these seconds per round. Right? Hence, this 60 need to go upside down. And this become upside down mean 1 upon 60. Right? Hence, this value will become 1 divided by 60. Okay? That is seconds of seconds per round. Now I'm going to the lecture note. You can see it now? No. I need to go to the lecture note. Yeah. See 1 upon 60 people, and that will be 0.0167. And now R by 2, we divide by this value by 2, and it come to 0.083. Now L upon D, L, the size of the block, because T calculated is for a block. L now, the bytes per block. Now it says blocking factor is 3. What is blocking factor mean? What is blocking factor?
Number of records in a block.
Number of records per block. How many records? How many bytes per record? How many bytes per record?
200.
Right.
200. 200 bytes per record. If 200 bytes per record, how many bytes per block?
600.
600, because 3 records. Say 200 multiplied by 3, we get 600 bytes per block. That is L. L is 600. L is 600, and it divide by the data transfer speed. That is bytes per second, 806,000. See, 600 divided by 800 and 6000 come to 0.0074. Guys, you see it? Now let me get this value, copy it, and let me go to the screen. My share screen. Now here control paste is what? Control V. Anybody know the how do I paste something here?
Control V.
Yes, sir.
Control V?
Yes, sir.
Yes, sir.
Thank you. You guys know, I know. But it
Yes,
didn't
sir.
work.
You're not give the participation girl for that.
Hold on. Before that it didn't copy. Control V. Alright, thank you. No man, that one I have to keep the respect for that one, Everything if I give, there is no value. But I know who is participating, I know who is, bright. Alright, anyway, now look at now. If you see now, look at here now. Look at this value. And this is this value. And this is this value. Now, if you notice here, 1 0, 2 zeros, and this is 3 zeros. Now, what does it mean? Look at here. 1 up, this is 1. 1 divided by 10 is 0.1. 1 divided by 100 is what? 1 divided by 100 is how much? 0.1. 1 divided by 1000 is how much?
0.001.
0.01. In other words, when you put 0 in the front, that means it is 1/10 of the previous value. Am I right?
Yes.
Yes, sir.
Yeah. And then this is 100 times smaller. So in other words, if I put this, compare this timing, this one, right, 10 times bigger than this second value. And the second value is 10 times bigger than the first value, this last value. In other words, this one, if we have this size, this one is 10 times smaller than that, and this is, it's like a dot. It's like a dot. See that? 10 times smaller than that. In other words, the third one, L upon D, 100 times smaller than the first. If time is small, that means negligible delay. So in other words, we don't need to worry about this. This is very small. We don't need to worry about R upon 2. That is also small. But the problem, the biggest elephant is A. In other words, time consuming to move a block of data actually cause in A, that is arm movement. In other words, if we can read the data without moving this arm, we can accelerate data transfer by 100 times. The problem is the arm movement. So that is where the cylinder comes. If you can put the data into a one cylinder, you can read whole heap of data in one shot without much delay. So in other words, when they put the data in the ISAs now. They are going to put into a one cylinder your first name, your surname, your ID number, and your modules. That's it. Anything other than that, how many times you did the O level, what is your O level results, your mother's number, your parents' number, blah blah blah, they can put into a different cylinder. Because when we enter grades, we just going to ask is your surname, your first name, your ID number, and my subject. That is what lecturers want. That is the most retrieved data in your portal. And that data, most frequently asked data, they put together into a one cylinder to speedify the data retrieval. All right. Say now you can understand A is the one most important because that is the biggest part, not R by 2. R by 2 mean tracks, right? The number of tracks.
So
Now,
I have a question. Quick
yeah,
question, sir.
yeah,
All right.
go
So
ahead.
like you said, the data is stored in blocks, right?
Go ahead again.
You said the data for each student will probably be stored in blocks.
Yeah, yeah. Data is stored as blocks. Yeah,
Right. And you said the most important data would be stored in like the first cylinder for
yeah.
easy retrieval, right?
In a cylinder. Yeah, in a one cylinder. Yeah,
But when you're retrieving the data, don't you retrieve the entire block so all together?
yeah. Blood one block. Now in a one track, right? In a
Right.
one track, you can put about um several hundreds of blocks. You know that.
Okay, I understand now.
Hmm. This is a one block. See, block is smaller. This is block one. This is block two. You can have another block, block two, and block three, right? Block four. You can have 100 of blocks. Clear?
Yes, sir.
Yeah. All right. Now we go into the second part. We're going to go until about 9:30. But what to do? Because I have to finish this lecture. Now read the second part of this. Hold on. But I send you guys this already, right? Read this one. I give you about 5 minutes to read, and whoever can explain this question, the answer is given here, right? And I give a 1 mark, past participation. You should be able to read this and explain this to the class. I give 1 mark. All right. Is 5 minutes. I just explain it you guys, but anyway you can go it. Are you reading on this one or you have your one?
Reading on yours, sir.
You don't need to read on mine. But when I put this one, share, right? You reading on mine, but when I minimize, But you can still see it?
Yes,
Yes,
sir.
sir. We still
Okay, all right, good. Anybody ready? Anybody ready? You want more time or?
So what's the question that we're answering?
Jesus Christ. Very interesting. After 10 minutes given asking the question.
No, sir. I read the
I
example.
am going to give one mark, I said, those who
Yes.
can explain how
Oh,
this one is work out.
okay. Okay. Cool. Okay.
Ready? I want to show somebody show the class how this work out, but you have to explain. But if you don't understand, you can't explain. Anybody there? Nobody? That's not what happened to the people tried before. I know Damien or Damai tried. 2, 3 people tried before. They want to try or they give up. People, otherwise I will go ahead. Should I go ahead?
Yes, sir. Go ahead, cause I gave up, sir, when it said 3 and 24,000 policy records, and then it assumed 200 bytes long. I gave up right there at the end.
All right. Now this is again trying to show how we can reduce the time consumption by putting the data in um, data in um, um, what do you call
Sequential.
huh?
Wait.
I don't hear you.
No, I was saying on putting the data in sequential.
Exactly. Sequential. That is the key point. You put the data in a sequential, because if you take a database like batch processing, that is we used to do old, like a payroll. We put
Yeah.
payroll is a batch processing. It other one is credit card bill processing is a batch process. There are a lot of batch processing still going on take place. GCT filing, batch process. Now, here now, the data, when you know that you are doing a batch processing, if you put the data in a sequential order, you can reduce the time. That is this example all about. Now, what we do, remember when you put the data into a sequential, we have to put them into a one cylinder. You remember the philosophy? Sequentially. Now, one cylinder sequentially is, if you go to the, I'm going to go down little people, watch my diagram. This is how we're going to do. Look at this. We put as much as of data into this track, and then bottom side of the same platter, and if any remaining we put into this one, the top, and the bottom side of this, if we even have more, we put the remaining to this side, and if we have more to the bottom side, because that is in a one cylinder. Now what we need to know, how much of data we can put in this track. right? And then we can determine how many in this truck, how many in the bottom truck, because each one is a truck. All right, let us see how many. Here, all right, we have one truck can have 1000 blocks. See, one truck is 1000 blocks. It has how many? Oh, uh, all right, the 8000 blocks. That means we need how many trucks? How many trucks? 8 trucks, because it is 8000 blocks. We need 8 trucks, right? We have block and factor, yes, that is 8000. All right, that's what we need. Say we need 8 trucks. Clear? Now, as I show you now, because of it is one cylinder, arm movement is only one time, that is 0.03. That is the arm movement, A, only one A, because everything we put into a one continuous cylinder. But there are 8 trucks in the same cylinder because it has 4 platters. See? 4 platters, 4 platters, 4 platters. See that? This one is a one platter, has top track and the bottom track, 2, right? And the second platter, 2, that is 4, and the third, and then the fourth, right? 4 platters can have 8 tracks in the same cylinder, all right? And that is why we have one arm movement, but 8, because this is the rotation with delay. For 8 tracks, you have to multiply it by 8. The reason is this: for each track, the starting point, we don't know where to start. The first block here can be here. For this one to move here, it take R by 2 for that track. And the second track, we don't know where is the first block. It might be here in the bottom side. And that taking another R by 2. So 8 tracks mean there are R by 2 8 times. 8 tracks mean R by 2 is 8 times. So that is why we have to multiply it by 8. Now this one, L upon D, is per one block. Remember? This L upon D is per block because that is our formula. And we have 8000 blocks, mean we multiply by 8000. And then we get the value 6.0064. So when we save it, when we put it in a sequential order, we get for 8000 blocks, the time is 6.0064 because we sequentially stored. But if you divide this value by 8000, we can get the value per one block, right? Average value per block. So here the average value per block came 0.0075. Look at how small this one compared to 3 zeros in the beginning, and here is only 1 zero. It's 100 times better. This is the block time. time taken for one block. If you put a one block only. But when you put the blocks continuous, it make it smaller, 100 times smaller, 100 times smaller. When you put the records block sequential, the sequential storage for uh, batch processing, we can reduce the search time. That's the example show. Now the other one I want you guys to see, when you have sequential processing, right? When we have sequential processing, you can see we multiplied R by 2 into number of tracks, L upon D by number of records. But if we have another cylinder, we multiply this by number of cylinders, because for every cylinder the A has to move. Remember, because there was only one cylinder, we multiplied it by 1. Say, I am going to give you a formula now. I modify this formula here, this formula that we have it here, copy. Let me go to my screen. I'm going to give you a new formula here for sequential storage. For sequential storage, the formula T, this is for this is for many blocks, right? T equal control V right? I can for T for A multiplied by number of A multiplied by, let me put it here, A multiplied by C, that is number of cylinders, R multiplied by number of tracks, L upon C multiplied by number of blocks. The time here, time for sequential, that is I say TS, right? Time for sequential, multiple blocks of sequential, A multiplied by C A multiplied by C, not very good. I hope you can see. A multiplied by C, R multiplied by 2, and L upon D multiplied by B. That's the formula. This is the formula. C is number of C mean number of cylinders. T number of tracks. B number of blocks. That's the formula. That means anytime in the final exam papers you can see this is the formula you're going to use, because it always asks sequential storage of blocks, right? C is number of cylinders, T is number of tracks, B, and you use this formula and calculate. You don't need to think and think and think at the exam point once you use this formula. This formula is not on the lecture note, but I created it for you guys usage. Now, what we're going to do, you can see in the lecture note, there is a question. There is a question. Question next week, right? Week 2 tutorial. This is what we're going to do. Week 2. The group A, right? Group A will be doing this week 2 question, number 1 and number 2. Group A is Natasha. Are you watching, Natasha?
Yes, sir.
Yeah.
But the screen, I'm not seeing the screen, sir.
You don't see the screen. All right. Can you see it now?
Yes, sir.
Yeah. This is the bottom of the lecture note. Every lecture note, bottom of the lecture note, we have tutorial question. Now, the group A start in the tutorials. What you're going to do, you prepare this one. If you need help, let me know tomorrow. I will help you. Clear? And
Where's the question 1, sir?
week 2, question 1. Look at this. Can you see the screen?
Yes, sir.
Yeah, question 1 and question 2.
Okay.
Yeah.
For next week, for the upcoming tutorial class or the following tutorial class?
No, upcoming tutorial. We finish week 1. This is for week 2. Upcoming tutorial. That is going to be week 2. That is tutorial is when?
Wednesday?
Wednesday. Yeah, that is week 2.
Okay. Oh, yeah. Last week was week 1. Okay, sir.
Now, every week, right? That is what I will explain. Group now. Say week 2 is group A. Week B, week 2, week 3 is group B. Responsible for tutorial. But you guys need help, give me a shout. But don't wait until Tuesday night to call me and ask. Are you clear?
Yes, sir.
Yeah. But lab time, if you have issues, ask me the questions, and I will explain if you have any issues. But this one is very easy. This one is very easy. All right. Now the other one I wanted to tell you during at the end. Remember, Natasha? Now.
Want to bring labs?
Sir, that question is on Moodle.
Yeah, I sent it to Natasha already. The lecture note.
I'm going to share the lecture notes in the Telegram group.
Yeah, exactly. And then I will send you all the lecture notes also in a zip file and send it to them. Then easy. But
okay.
Yeah, this one I already sent. Yeah. Now, Natasha, there are past papers. Do you have any past papers?
I saw some on the UTech library, 2013.
Yeah. I will give you one more past paper questions also. Then you guys know exactly what is in the past paper. Clear? The next week, Wednesday, you're going to do 3 questions. The 2 questions I show you plus a past paper question. All right? Natasha, are you hearing me?
Yes, sir, I'm hearing you.
Yeah, you are 3 people in the group. Now the other one I want to talk to you, the lab. Now the lab assignment I'm going to send you. Lab project, not the lab design, lab project. In the lab, what you are going to do is the implementation of the database design project. You remember you did the database design project? Hmm?
Yes, sir.
Yeah. You design it. Say, for the next class, you're going to bring the database design project. Per group, only one I need. But in your group, you have 3 people, select the best one. Now, this is what I need. Next class. I don't need the whole project, but what I need is, I'm going to write it. All right, let me save it. All right, I save it. Now I can. All right, now lab week number 2. Now week number 1. What I need tomorrow, number 1, database design lab project. One, case. Remember the teacher gave you a case. Am I right? ERD, corrected one, not the wrong one, corrected one. 3, normalized.
Sir, when you're asking for the lab project, you want the SQL, right?
Hold on, normalization. Hold on, normalization. That's what I need. Your case, your entity relationship diagram, and the normalization. But normalization also the corrected. That's it. Nothing else. Now this one you get 5 marks. Because of night now, I can't show you. I have the schedules, and I'm going to send you the schedules to Natasha now. You will get several emails from me.
Okay, sir.
Yeah, they distribute all of them. Now, case, ERD corrected, and normalization corrected per group, right? This is what I want for next class. Whoever bring it, I give the 5 marks.
Sir, so I was wondering if you wanted the SQL or you wanted the project that we did with they gave us the scenario and we had to do the ERD for it.
The database design, you get a case to do a ERD and do the normalization. Am I right?
Yes, sir. Okay, I get it now.
Yeah.
Just because that wasn't our lab project, so I was kind of confused.
That's kind of what?
That wasn't our lab project. It was a group project thing.
So you get 2 projects? In other words, 2 cases?
No, sir. Like the one with the case, that was a group project,
Hmm.
and then the lab
Hmm.
we got one each week.
That's like a lab manual.
Right.
Yeah. Say But normally, I mean, I used to teach database design long time ago. What we do is you get a case, and then you do the ERD, and then you do the normalization, and then you implement the tables and views. That's it. We stop over there, and when you come to the database, the advanced database, you can you go to the rest, like full implementation with the screens and back end and front end connection. You get what I mean?
Oh yes, sir. I get that too.
Yeah, that's what we used to do. But I do not know whether you this new teaching now. I think Mrs. Allen and Mr. Williams, right? Miss who is teaching database design now? I really don't know who teach.
I think
Mr.
it's
Thomas.
Mr.
Huh?
Thomas.
Oh, Mr.
Mr.
Thomas.
Thomas.
Oh, Mr. Thomas. Okay, Mr. Thomas used to teach for a long time. Yeah, that means I don't think any, because you have a case and you have a database design, but I don't know whether they give you, they ask you to correct it. When we were teaching, when I was teaching, we asked you to correct. We mark it. We give it to you. When you correct it, then we give the mark. Do you
Oh,
still do? Hmm?
I don't know if we got it back to correct, but I know we did that ERD. I know that much.
Did
I
you
don't know
get
if
it back? Did you get the corrections back?
I can't. I don't remember.
No,
Not
sir.
nothing, not in my case.
All right, sir. This is how it went when I was doing it, cause I did it last semester.
Hmm.
So when we were doing it,
Hmm.
like in the tutorial classes, you could show the teacher what
Hmm.
you had so far. He didn't mark it. He would just look at what you had so far and tell you if it was right or wrong, and tell you what you would need to add, and then he would just mark the final thing and you get the grade. There wasn't like any corrections to be made or anything.
Oh, okay. But you know how to correct it because he gave you what is right, what is wrong, right?
In a sense, sir.
Okay. Now let me get a screenshot of this
So,
because
so,
hold on, Natasha, hold
I'm
on.
sorry.
So these are the cases you guys going to say that you don't know. All right. Did you get a screenshot, Natasha? Oh, hold on. I sent to the wrong person. Hold on, hold on. Natasha, I send you a WhatsApp message. Oh my God, two Natashas are there. All right. I send you a screenshot. You can forward to everybody. Natasha, can you see WhatsApp?
Hold on. I got it, sir. It's forwarded to everyone.
Yeah, forward it to everyone. Because do not tell me that, sir, we don't know what to submit. I give -5 marks for that. Especially the people those come late.
Oh,
Natasha, you have to distribute the information to everybody. Clear?
yes, sir.
Yeah.
Yes, sir.
So even last semester there was a one group failed the project. Failed. I don't know. I mean, I really don't know what to do with them. But once you project failed people, I cannot push you in the final exam. Project has very high marks. I want you guys to take serious, and I will invite tomorrow Mr. Dylan. He is very helpful. He is the lab technician, and he is a very highly educated man. He has done his masters in databases. He is very helpful for you guys. Work with him, Natasha. I don't want anybody to fail. This is a 4 credit course. You guys know. Am I right?
Yes,
Yes,
sir.
sir.
Yes,
Yeah, you
yes,
can't
sir.
fail this. It's expensive. About 50,000 you have to pay again. There are a lot of works to do, but it is not hard to do. You get help every minute you turn. If you have issues, discuss, let me know. I give you the help. But if you stay away from work, I cannot help, right? I cannot help. You have to continue doing the work. All right. Say, I think we did. I am going to send you Natasha schedules, two schedules, lab and lecture schedule, and the total lecture notes and the two books. 3 emails, I think I can send it. I use WeTransfer for those. Clear?
Okay, sir.
All right.
Sir,
People, any questions? Any questions?
Yes,
sir,
sir.
Huh?
sir, are you hearing me?
Yes, very pale. Your microphone, what you are using? A microphone or what?
No, no, straight from the computer.
Yeah.
Sir,
Yeah.
pertaining to the recordings, right? Would have to wait until Moodle is up to get it.
Get what?
The recording.
No, I have nothing to do with Moodle. I am paying for Zoom from my pocket. You know why? This Moodle every semester first 2-3 weeks down. Last semester my Moodle sites were down 5 weeks. So that is why
Oh,
this is not UTech money, my personal bloody money I spend to run UTech business. Because I
okay.
want to teach. I want to teach.
Yeah, so I'm saying, how can I access your recording, or will I get it through Natasha?
Yes, immediately after. Not
All right,
immediately after. It takes
all
45
right.
minutes to format and then 20 minutes to upload. It will take 1 hour, but if you don't get it tomorrow morning, cuss her, because that is the last thing before I go to bed I do. I send it to Natasha. But the
Yes, sir.
other
I'll make
one,
sure.
hold on. Natasha,
Yes, sir.
you need to get assistant quickly because you can't do everything. Because it is not like a peacetime time class trip. This is a COVID time. Low leap of things, online communication. Who can help Natasha? Who can help
I'll
Natasha?
help her. I'll help her, sir. I'll help her.
All right, Janoi. Now, what
Yes,
Janoi
sir.
going to do? But both you guys are Thomas, husband and wife.
No, sir. No, sir. That's coincidence.
It's all right. Just
Sir, good
all
question,
right,
sir. Good question.
Janoi, send me an email. What Natasha, you can subcontract him and monitor whether he's doing the job. Now, when I send it to both of you, send me an email immediately. I will send you both. You're going to create a Google account and put all the recordings, upload into that Google site and share the link. You get what I mean?
Yes, sir.
Yeah,
Yes, sir.
that is what last class did. But people, you definitely need to ask if you do not get it from them before end of the day. I normally send it before I go to bed. Clear?
Yes, sir. I'll make sure to cuss them if I don't get it.
Exactly, that is Leon. All right, if the class says they don't get it, I'm going to cuss you, Leon, now. All right, 3 people in charge now. Good.
Okay, sir.
All right, people, enjoy your rest of the evening, but get serious about advanced DB. Get
Sir.
serious. I'm telling you in advance. I think this is the only 4 credit course you do this semester. You cannot afford to fail. And don't come and tell me in the end of the semester. Last group, I was not very happy with their performance. Every minute they don't want an extension. I cannot give extension because exam date is not postponing. They are not postponing exam date. How can I give you an extension? So hence don't come and ask extension. If you want extension, you ask him. That is what happened last semester.
Sir,
Everything backpedaling. Yeah, go ahead. Yeah, what's the question?
yeah, I'm doing 3-4 credit courses semester. I think that'll survive, sir.
What are the other two?
Physics and data structures.
Jesus Christ. I didn't know physics is 4 credit. That is new to me.
Oh,
Yes,
yes.
sir. It's 4 credits. 4 credits.
But we did physics at CXC. We never did physics at the university. I can't believe this is the problem in Jamaica, man. The things that we need to do at CXC, we do it at the university. I can't believe.
Physics for computing, sir.
What is physics? You learn semiconductors. Am I right? That's the only physics you need for computing. What else you learn? Hmm? What is the physics that you need other than semiconductors for computing? Tell me, no. 4 credits, 50,000. I cannot believe this. Hmm?
Yes, sir. Them say it's a prerequisite for one of the networking courses, sir.
I don't. These things can be what we need. In here, boy, I don't know. We need to have advanced level. It is cheap. In Sri Lanka, advanced level is free. A level physics, when you do everything you need to learn, we learn free at high school for advanced level. Now what we have done, advanced level we don't do it, don't teach it, and O level we don't teach physics here, and then move all of them to the university and charge you guys. And that is why you have to go and work to pay university. You see, the physics, I don't know, but you guys need to talk to your MP these things. Students need to teach physics in high school. But anyway, um,
Yeah, I was asking if you'll be sending the lab manual tonight also.
oh, you lab manuals. I will send you lab manuals. Yeah. Normally,
Okay,
Mr. Dylan send you the lab manuals, but I can send you. Yeah,
okay, sir.
because lab manuals are due from next lab. Yeah. All right. Now, if I don't send you now these 4 things, send me a reminder for 4 things now, Natasha. Then I can tick one by one. 4 things I have to send you: schedules, lab manuals,
Hold on, let me write that down.
books,
Schedule,
books, and lecture notes. Yeah, four things.
lecture notes, and lab manuals.
That's four things I promise.
Yes, sir.
Yeah.
And
And
the
you said
video.
recording at the end of the night.
Oh, 5 things. 5 things. Yeah, 5 things I have to
Record.
do. Yeah.
Okay, sir. Send me an email reminding me.
Yeah. Yeah. You can send an email or WhatsApp. Then I can tick it. Otherwise, my brain, my memory lose immediately now. All right. I'm going to get a shower very late, but what to do? That is this online teaching work. It goes and send the people. There were 3 more people. Sorry, 2 people who registered day before yesterday when I checked it. No, last week. There were 80 students last week, and I see only 6 students in the class. That means 2 missed the class, but there may be more registered by now. Say, Natasha, you need to find them out. If they are not coming next class, tell them not to come. I cannot keep repeating and repeating everything. I'm not going to repeat anything, but the the tutorial class that I was supposed to do on Wednesday, I'm going to do it because of nobody came to the class. Yeah. All right. Good night. Anything else?
No. Good night, sir.
Good night, darling. All right. Good night, everybody. And tell the man to send me an email. Did he send an email, the assistant?
Jonah?
You will, you will, sir.
No. Send it right now. Don't postpone it.
Yeah, I'm saying you will.
Sir,
I'll remind.
Yeah, because I have to
I'll
send
get
the.
an email from Natasha and send you the email, sir.
Yeah. All right. Thank you. January, send it right now. Don't postpone. Postpone mean you don't do it, then I can't send them recordings. Now, 2 people I'm sending the recording. Natasha and January both. Yeah. All right. All right. Good night.
Good night, sir.
All right.
All
Take
right,
care.
sir. Good
Take
night,
care.
sir.
Good night. Good night. Why it is not ending? End meeting. What is happening?